Hello, welcome back to Preppy Maths, 15-minute maths. It's week one, the end of week one of a 10-week course to help you boost your maths skills. If you're homeschooling as a student or a parent, this is here for you. I will go through all answers once you've had a good go at the questions. So if you can pause the video right now, have a good go at those questions below. There's the other ones. So you pause that video right now, then pause again in a moment. So pause the video, have a good go at those questions. And below there's the remainder of the questions. Have a good go at those. Don't forget to time yourself. Give yourself a timer. See how long it takes you to go with these questions. And we'll get straight into the answers. Here we go. Some missing digits to start with. We've got something plus 6 is 5. That wouldn't make much sense unless we had some carrying going on. So it's 9 plus 6 is 15. 5 tens plus 1 10 plus one more 10 would be 7 10. So well done if you got that one right. 8 plus something ends in a 2. So 8 plus, what would it be? I think 4, wouldn't it? 8 plus 4 would be 12. And then something in the tens plus one more 10 plus one more 10 is 4 tens. That's 2. So well done if you got that one right too. Something take away 9 is 9. It's not 0. 0 take away 9 wouldn't be 9. I think we're going to have something like 18. 18 take away 9 is 9, which means we must have borrowed from here. And then 7 take away 4 would be the 3. So well done if you got that one right and you took account of all the carrying. Here we go. 0 take away 5. We can't do it. Let's borrow. And then 10 take away 5 is 5. 6 take away 8 you can't do, so you borrow from 60. That's 59. And then we get 16 take away 8 is 8. 9 take away 9 is 0. 5 take away 2 is 3. Very well done if you got those two right. On to the next questions. A multiplication, bit of multiplication. 7 eighths are 56. 4 eighths are 28 plus the 5 is 33. And 1 7 is 7 plus 3 is 10. 1036. Very well done. 3 digit multiplied by 2 digit. Let's see how we go. 6 times 6 in the units is 36. 6 zeros are 0 plus 3 is 3. 6 fives are 30. In the tens, we're multiplying by 40 here, not by 4. So we have 0 in the units. 4 sixes are 24. 4 zeros are 4 plus the 2 is 2. And 4 fives are 20. And then we add 6 in the units, 7 in the tens, 2 in the hundreds, 3 in the thousands, and 2 in the tens of thousands. Very well done if you got that one right. 8,435 divided by 5. 5s into 8 go once. 1 5 is 5 with a remainder of 3. 5s into 34. 6 5s are 30 with a remainder of 4. 5s into 43. 8 5s are 40 with a remainder of 3. 5s into 35. 7. Well done. 45,024 divided by 12. Try not to use long division if you can. Please try and keep those workings in your head, and then it reinforces this idea of a remainder and how multiplications and subtractions all work. Sometimes if you use an algorithm method, you might not be quite sure why that algorithm method works. 12s into 4 don't go, but 12s into 45, 4 12s are 48. We don't have enough, but we have enough for 3 12s. 3 12s are 36, and the remainder is 9. 12s into 90, 7. 7 12s are 84, the remainder is 6. 12s into 65, 5 12s are, 12s into 62, 5 12s are 60 with a remainder of 2, and 12s into 24, 2. Very well done if you got this one right. Let's look here. At the side of the page, let's do 17 multiplied by 5 because we're doing 170 times 50. But I think we can just do this method. So 5 times 7, 35. 5 times 1 is 5 plus 3 is 8. So we get 85 for 17 times 5. But it's not, it's 170 times 50. So there we are. That's our answer. The answer here is 4.3. We're going to be doing some more work in the coming weeks on decimals and how we use them. So if you're not sure about that one, we'll come back to it. BODMAS, BIDMAS, BEDMAS. We do our divisions before our subtractions. 24 divided by 6 is 4. So this is 17 subtract 4, which is 13. Again, multiplications before subtractions. 9 eighths is 72. Whoops a daisy. 9 eighths is 72. 4 6s are 42, and if we subtract, then we get the answer 30. Find the next two numbers in the sequences. I think this is an increasing number sequence, and I believe we're increasing by 8 each time. Yes, 8 each time. So let's add 8 here. So that would be 57 and then 65. This is decreasing. So we're decreasing. I think we're subtracting more than 10 each time. We're subtracting 12 each time. So let's do that. That would be 30 and then 18. Very well done if you got those two correct. These last two problem-solving questions, I've been setting you one on time and one on kind of amounts of things, starting with a less than or a greater than. We've got a 10:45 p.m. flight. I was careful to keep the departure and arrival in the same time zone here, and we arrive at 9:08 a.m. the next morning. I think my technique I've been trying to get you to use is to use whole number hours. So we're going to count up to 11 p.m. Mr. Daisy, let's try and just rub that one out and write a P there. That should have been a PM, not an AM. So we're going to count up to these whole number of hours just to keep track of what we're doing. Midnight is 12 a.m. We use AM at midnight. So let's have a look at if this works. We're going to count up there. The flight takes off at 10:45 p.m. 15 mins later, it's 11 p.m. 1 hour later, it's midnight. 9 hours later, it's 9 in the morning. And then 8 minutes later, it's 9:08 when the plane lands. Add all of that up, and I think you get 10 hours. And 15 plus 8 is 23 mins. Lovely. That technique of using these whole number hours to count time, either forwards or backwards, it's quite a nice, neat way of doing it. And the last problem, it's a bit of a harder problem than we've had, but we're going to try and use this Singapore method that we've used before. This idea of using these lozenges or rectangles to signify how much money each person has. So getting myself in a bit of a pickle there. So it's question number 15. Let's do the shapes. So it says Jackson has $10 less. So Jackson, this is Jackson's amount of money. There's Jackson's amount of money. It's not to scale in these squares at all. It's just a representation, a visual representation. He's got $10 less than Janet. He's got less money than Janet, so she gets a bigger rectangle. And Janet has the same amount of money as Jimmy. So these two have the same size rectangles, same size lozenges. There we go. But we're told that the difference in the money, there we go, the difference in this amount of money we're told is 10. Jackson's got 10 less. 10, so that's 10 less. That's 10 less. 10 less dollars. And we're told the total amount of money is 140. Altogether, this is worth 140. So I think what we can do is you can do 140. We'll take away this $20. It's 10, this 10. That's $120. And then these three parts of the rectangles are now in equal size, aren't they? Because we've taken these 10s off. They're in equal size. So we want to do 120 divided by 3 to find out the size of each one. And that would each be 40. So these would each be 40, 40, 40. Add all that up and you get $140. So it's the correct answer. But we haven't answered the question because we're asked how much does each have. So we now have to list exactly how much each person has. And I just need to remember the names. It's Jackson, Janet, and Jimmy. So Jackson would have $40 as 40. Janet has $10 more, so 40 plus the 10 is 50. And Jimmy has the same as Janet, which would also be 50, and together that makes 140. So very, very well done if you got that last question right. Please please subscribe. It helps me track who's doing this and where they are. And well, I don't know where you are. Can't do that, but it does help me to track how many people are watching. And if you've got any feedback, you can leave a comment and I will cover whatever you think needs covering to boost your math skills for high school. But thank you very much. And that is it for week 1. See you during week 2. Bye-bye.